Hello everyone. Uh, this is Bisal Lakha here. So welcome to the first Pi and AI meetup Bhaktapur. The meetup is organized by engineering students group of Bhaktapur. So I will like to request the uh, current president of ESCB, Mr. Rasik Shrestha, to give brief introduction about ESCB. Rasik is not available now, so I will give a brief introduction about ESCB myself. ESCB is an assembly of students from Bhaktapur who are studying in IOE Pulso campus, and it was established in February 2002, and from then it has been conducting different programs. So this program is the first online event conducted by ESCB. Today we will be having two speakers, Mr. Pankaj Saha and Mr. Sujan Bandari, and they will be talking about web development and AI and how uh, they are interlinked and how to begin in machine learning. So before we do that, we have a short message from Professor Andrew Ng. He is a professor at Stanford University and is also founder of deeplearning.ai. So let's start that.
Hello, deep learners. I'm the founder of Deep Learning AI and excited to welcome to a global deep learning community. I know that many of you are here today because you want to break into AI. I hope that being part of this community do so. To give you a proper welcome, I'd like to show you around the deep learning architects and meet some of the teams. Do you want to tell our friends at Pine AI what you do at deep learning?
Sure. I make articles and other media that help people learn about AI and them understand the huge impact that AI is having. Today, I'm putting together the next issue of Batch, our newsletter, and I'm looking for the biggest stories moving to our readers.
What's been the surprising thing you've learned?
How much there is never. You might think from the outside that machine
र विशाल दाइ त्यो साउन्ड आइरहेछ नि राम्ररी
but nobody can understand.
Sound छैन?
Life right before my eyes as I put this thing together every week.
All right, I know you're really busy, so I'll let you get back to it.
See you later.
त्यो अगाडि देखाइहाल्नु फेरि
Kian, who helped me create the deep learning specialization. He's working on an exciting new project. Hey, Kian. So, do you want to tell the people at Pine AI what you're working on?
Yes, sure. I'm leading a project called Workera, focusing on helping people get offers in AI and navigating their career by testing their skills, preparing for interviews and certifying them, as well as matching and referring them to good jobs in AI.
That's really cool. And what's the most exciting part of your day?
The AI field is new. Organizations and jobs are still misunderstood. So I'm excited to help people understand what different types of jobs exist in the field, what tasks they will work on, and what skills are needed to achieve those tasks.
That's really important work. Well, it's nice chatting. And now let's go chat to Hotel, who is on their product team.
Hey, Andrew.
Do you want to say hi to our friends at Pine AI and let them know what you're working on?
I would love to. Hi, everyone. I lead the product team in deeplearning.ai, where we create AI education content accessible to people all around the world. People like you.
And what are you most excited about right now?
I am so excited to see our community grow and to see how eager people are to learn more about AI.
Thanks, also. So, as you can see, our team is working hard to support you and help you learn. It's never been easier than before to break into AI. So if you want to build a career, you can leverage online resources available, including open source code, datasets, papers, and online courses like a deep learning specialization on Coursera. As part of this journey, I hope you get your hands dirty too. Don't be afraid of diving in to build your own project, or go ahead and try to replicate a research paper that you're excited about. One thing that I've seen help a lot of people succeed is if you can build a community or find a community of fellow deep learners you can meet with and study with on a regular basis. In fact, I hope that this Pine AI meetup that you're at right now will be a good place for you to meet these people. I hope you enjoyed the event today and that you learn a lot both from the talks and from each other. And once again, welcome to the deeplearning.ai community.
Hello, everyone. So are you being able to hear me?
Yeah.
So now we will move on to our first speaker, Mr. Pankaj Saha. Mr. Pankaj Saha is machine learning engineer at Neuron Technology. He worked as a web developer for past 3 years, and he have recently switched to machine learning engineering, and he has been working in computer vision and speech processing since then. I will like to ask him to start his presentation.
Hello everyone. Good afternoon. I hope you are doing well. So today, it's like more of my personal experience rather than a formal presentation. I want to share my experience while I was transitioning from a web developer to a machine learning engineer. So I'm Pankaj Saha. I'm working currently as a machine learning engineer at Neuron Technology Private Limited. So let's begin. So first of all, I would like to give us talk about my background in short. So I completed my BE in Electronics and Communication Engineering in 2016 from Untitled campus. Though I joined BE Electronics and Communication Engineering at the end of my study, I was more intrigued and interested in programming. So I was mostly into the programming parts, and due to that shared interest, I also took artificial intelligence, database management system, and image processing as my elective subjects. And also due to the interest in AI, we plan to do a final year project that somehow implemented AI. So we plan to make a automatic robotic system that could identify and pick up the ripe tomato and distinguish it from the other objects and pick it up and separate it. A small uh, uh, view of that project was this. So firstly, uh, we plan to make a robotic robot itself that could be deployed in the tomato farm and pluck the ripe tomatoes on itself. But due to the mechanical constraint, which we had to switch to the switch and change into the industrial system. This system could this system could identify the ripe tomato and pick it up and separate it from the non-ripe and other objects. So after completing my engineering, I got internship at EV Post Private Limited, situated in Lalitpur. Um, uh, I had no professional experience before that. So to get professional experience, I decided to join what I got at the beginning. So after 3 months of training, I was appointed as a web developer. I worked in PSP, Laravel to be more specific, in the back end as a back end language, and I use jQuery and Vue.js for the front end languages. I I started to so after working for 3 years, I started to feel I started to find the work monotonous. I also felt that the learning graph was a bit slowing down. Maybe it was simply because of the projects I was involved in. It might not be case with everyone, but due to solely because of the projects I was involved with, might have made me feel so. So uh, I was in a pretty comfort zone, but I was not fully satisfied. Uh, so I tried switching jobs, but it's still the same. I tried switching jobs, it's still the same. Still, it was the same. So after a few months of working as the freelance developer, I got to know about my friends working in AI, and they were starting companies. So I joined them. I joined them as a machine learning engineer since then. So what was the basic differences that I got while I was switching from web development to machine learning? So web development was more of designing, coding, and modifying the websites and creating the web apps that met the client requirements. Uh, uh, and the machine learning, on the contrary, in machine learning, it was more of data collecting, data cleaning, the model generation. It was mostly about the experimentation that could be done to obtain and create a model that could be used to meet the client requirements. So if you see the languages, in web development, we mostly use HTML, CSS, Ruby, PHP. In machine learning, R, SAS, Julia, and now we can use Java, JavaScript, Python, SQL, Scala, and ASP.NET in both. These languages can be used to integrate both of the parts. So, what skill sets can we develop uh, while doing the respective things? While in the web development, we mostly learn about designing, web app security, SEO, server management. On the contrary, in machine learning, we develop the skills of statistics, predictive modeling, visualization, and to do both, we need to learn about version control. One of the example is Git, and about databases. So, what were the challenges I faced during the transition? The very first the very first challenge was the language itself. While doing, as I mentioned earlier, while working as a web developer, I used PHP as the language, but in ML I used Python as the language. So the language itself was it's a bit challenging for me to switch initially. Initially, while working as ML engineer, I also worked as a freelancer uh, uh, I was working as freelancer and I had to complete the project. So working in Python during the daytime and in PSP in the at the evening was a bit taxing. It was a challenge for me. The braces, those semicolons, those dollars kept on coming in Python too. It was a bit irritating at times. So another challenge was maths. The one of the major reason I switched to machine learning was because I could not use the maths in web development. I was pretty interested in maths from my earlier days, but in web development I was not able to use it to my full extent. I decided to switch to machine learning. But while diving deeper into machine learning, I found the same maths can be daunting at times. The linear algebra, the statistics, probability, the vector matrices, surface indications that we learned during engineering days was a bit surface. It was at the surface level, but while doing the ML part, I had to go into much deeper, and it turned out to be daunting at times. At times, I pretended as if I understood everything, and at times I had to escape some of the chapters too. So another challenges was the thought process. So what I mean by thought process uh, was approach to the two different things. Uh, the earlier While working as the web developer, an approach to solve a given problem was different than working as the ML engineer. In web development, I used to plan everything on paper before starting a task given being assigned to me. I made a plan everything on paper, and decided I will do this, and I will finally reach to that outcome. But in ML, it was a bit difficult for me to write everything on paper because it mostly is about experiments, and changing the parameters of the models to reach a definite type of models that is required. Moreover, in addition to that, comparatively, I found a lot of research goes behind in ML, in comparison to web development, and also the lot of experimentation goes in the ML. So another challenge was the data collection. Uh, uh, After joining as ML engineer, I was assigned into a project that needed to identify the person who are wearing the PPE or not. So to find the data, we googled a lot, but we could not get the required amount of data for that project. So we had to create our own data, and it was very difficult, and it took a lot of hours to create that data initially. Another challenge was the dynamics of the field. The machine learning field is comparatively more changing every now and then, and it's sometimes very difficult. Gets very difficult to keep up with the pace at which ML is changing every now and then. So, was it very difficult and new everything for me to switch from the web development to machine learning? Probably no. I got some help from my previous programming experience. It was not like I was very new to the world of programming, and also I did some projects at college, so it helped me a lot. And also the programming experience in web development could let me focus on the theoretical and core concept of machine learning rather than learning about programming. uh, and also the courses suggested by my friends were very handy for me to get the core knowledge about machine learning and AI. The very first course I took was machine learning by Mr. Andrew Ng, available on Coursera. That gave me a core concept about machine learning. Though the language used in that course was MATLAB, but I saw the video parts and I got in-depth knowledge about machine learning. The next the course I took was deep new learning specialization at deeplearning.ai. It is also by Mr. Andrew Ng. It contained five more subtopics as shown in the screen. I'm currently taking fundamental of studies on edx.org to get a bit more information about statistics. Another course we can take is mathematics for machine learning available on Coursera. It gives in-depth knowledge about mathematics and the process, then the phenomenon by which the mathematics can be used in machine learning. So my journey so far. So I'm not fully grown into a senior machine learning developer. I'm still in learning phase and I'm still want to learn and dive deeper into that this thing. Uh, and but as far so far I have been involved in quite interesting projects. One of the major projects I am involved in is sports analysis. It requires several aspects of ML, computer vision, to solve the problem. It also involves action recognition, which was challenging for me, and I'm getting new things to learn. Another project I'm involved in is integrates speech to text. That is quite handy and is very helpful for me to learn about language used in AI. Another, as mentioned earlier, the another project I'm involved in is security equipments detection in Pi. So my some of my short terms and long terms plans and goals I've created for myself, yeah, as uh, firstly, not only I but every developer at our company are planning to learn and dive deeper into the field of AI and develop a research culture not only in our company but in our community, in our Nepal, in our country itself. And personally, I also wish to integrate AI and ML in web development, and not different, make these two fields totally isolated from each other. Let's see what to demonstrate that. I would like to show what some of the first websites look like. This was the first website developed. This is not the exactly the website, but the more of the exact copy of that. Another one was this. So these websites more of look more of like a page from a book rather than those of the websites at present. Web 2.0 changed the way people interacted with the machine. They were more involved and interacted more uh, extensively in in the internet. They also, yeah, with the growth of YouTube and Facebook, they also could was able to leave their footprints behind. Also, the JavaScript and advanced CSS changed the way one got involved in the internet. uh, the, so there are more scopes of developing this interaction with websites. This can be more developed, integrating AI in web. We can already see AI being implemented at different websites. The very familiar is the Facebook itself. They are using AI to recommend the posts, the friend suggestions, the posts, the advertisements they are showing to us. Everything is using AI and using our data collected by them. Also, the advertisements and the search we do, Google are using AI. The videos, similarly, the videos we are video suggestions we are shown on YouTube are also done using AI itself. And also some of the e-commerce websites one of the primary example is Amazon. The product suggestions they show, so the product suggestions they show is using AI itself. So we can do more in addition to these. Some things we can do is uh, making website behave in according to the user emotion. We can develop the UI and UX more in according to how user is feeling. And also we can integrate speech to text in e-commerce websites. This can be pretty useful in customer retention, as we can see the normal person would like to interact more with website uh, verbally rather than typing and finding some products and filtering itself. If we can integrate and develop speech to text in e-commerce. This can be used for customer retention. The data collected also can be used for showing them ads. And another thing which AI integration in web can do is they can uh, make these websites more accessible to the visually impaired person, the person who cannot see and read perfectly, can more interactively deal with those websites. So I would like to end this presentation with a question. So is AI threat to web development? Definitely no. Yes, we can see several development in the field of ML that are saying that are promising to replace web designing, uh, replaced by the ML itself. And also uh, just recently I saw a model that was generated by OpenAI that could uh, generate SQL queries based on our the normal English language we talk. But definitely these will not totally replace the web development and web developers in our field. Uh, uh, the recently I saw this. I found it quite interesting. So I thought of putting it in my slide. It said that to replace programmers with robots, clients will have to accurately describe what they want, so we are safe. As per my experience working in the web development field for 3 years, most of the times the clients cannot express what they actually require. So however the ML field would progress, this will not be there. Will the web developers will not be replaced at least for 10 years. And also, another question I would like to add here is, but do web developers need to explore AI and ML? Most likely, yes. I say this because uh, yeah, as we are in the field of technology and IT, why not explore the different fields that could integrate everything and hone our skills in the future? So, thank you.
Uh, Thank you, Pankaj Saha, for your presentation. We will be back to you in our question and answer session. So moving on now, we will be requesting Mr. Sujan Bhandari to present his presentation. Sujan Bhandari is co-founder of Funka Technology. Uh, he has more than 6 years of experience in web development, and he is currently studying masters in computer science in Technical University of Kaiserslautern, specializing in artificial intelligence. Uh, uh, I will like to request Mr. Sujan Bhandari to start your presentation.
Yes, sir. Thank you, Vishal. Thank you for your introduction. And I really like to thank Pankaj Saha also. Really inspiring presentation. So let me see the screen. So is it visible?
Yes, yes, yeah.
Okay, cool. Um, so I think Vishal already introduced some of the part what I'm doing. Currently, I'm I'm learning theoretical foundation of machine learning in the university, and along with that, my research focus is more on the side of interpretable machine learning. The idea is like you have seen, Pankaj explained, there are so many domains where machine learning has been applied, but eventually what happened is once you deploy the model and everything happen, but people don't know what is happening inside the machine learning, that actual model you design, because it seems like a very black box to the customer or the clients, whoever trying to use it. And this is a mere concept, because most of the time that models we are designing are based on the very traditional kind of machine learning algorithms, like linear regression or support vector machine. Those are very interpretable because they have a specific geometric interpretation, or anything that can be interpreted really well. But when you turns into a neural network or deep neural network architecture, and it seems quite lousy, because nobody knows what is going on inside there, how the features have been mapped, or what are the importance of the features that a network trying to understand, or what are the patterns they come up with. So these are very challenges, and then and people are working on it very in very large domains, and I'm continuing my research on the same area. So let me begin with my presentation today. So I'll focus most on the theoretical side of machine learning pipeline, where when you start some project, or when you're writing some blog on the content of machine learning, what are the basic components, or what are the basic questions you should consider yourself before writing your answers. Because there are lots of resources out there in the internet, and it's too much of distraction. I think you can also follow that, because of that, somebody want to say something about the machine learning problem, they just simply do some process, and pre-processing, design some model, and then show some output. But that's not the end of the machine learning. There are so many things and the consideration you have to put before approaching machine learning problems. So in this regard, the whole machine learning pipeline can be put into three different components: the feature engineering and representation, modeling evaluation, and serving monitoring. So once these three components are done independently, or in along with the pipeline, then you have to use that model, right? So there comes the web part. So how you deploy that models into some of your maybe the cloud, or some serverless architecture, and then how to solve those model in terms of API, or you want to embed inside your programming framework itself. So those are the options. So the first thing in the feature engineering and representation is the idea of how to make sure you handle the different kind of the outliers, the missing values, duplicate, and the imbalanced data. But most of the time when you see the content on the internet, you will find that people, they mostly talk on the missing values. They barely touch about the outliers or the imbalanced data, because these have the very high impact on the your output of the model. And here is one of the example that I put for the missing values using mean imputation. So there are so many other approaches how to handle this kind of fallacy in your data. For example, if you have the imbalanced data, that imbalanced data could hamper the out accuracy, because the accuracy is not a good model performance metric. Because if if your if your data has only classes from one of the class, and uh, very less number of training instances from the other class, then the whole model will be biased toward the one side, and then you never gonna know well using the accuracy alone, because you have to come up with other measures in between. And there are so many other ways to handle this kind of things. Like for in case of imbalance, you come up with the oversampling, downsampling approaches to mitigate those problems. The second question you have to ask yourself is whether my representation is good enough. because the representation makes lots of sense when you have a relevant problem at your hand. For example, why the representation makes sense? Because the whole idea of machine learning is you want to come of learning some patterns in the data, but how to make it more computationally achievable, that's a very very concern in the machine learning community. So the representation is more about how to present your data, like we do in case of Python. We represent in terms of tabular structure or numpy array, right? So those are the structure that we come up with, but in between each individual features have a very different story. So we have to cover those features into some way to use as a numerical values, or so that we can use in the computation. So here is one example of idea of normalization. In the salary that I present in the slide, I convert into normalized values, because I mean this makes more sense when I normalize into these smaller tiny values, because when you have the normalized value, one of the most important thing is your training will be pretty fast, the conversions will be fast in a case. And another thing is if you have some outliers in your data or very fluctuated high values, then it will come into the same scaling values, so that I mean eventually the if you applying some stochastic gradient descent, the conversions will go very smoothly. So those are the very theoretical aspect of your training process. And the another part is how to reduce the dimension of your data. So I mean this is the very useful case. For example, when you have very large data set and you have very large feature dimension, then you are, I mean, kind of good to go. The thing is, there is a challenge if you have a large number of feature dimension but very less number of data samples, because in that case you cannot model, you cannot exactly get the patterns out of it. So you have to make the consideration on that. So in those cases we have to reduce the dimension of features. And as I mentioned here, large number of features will also are the part of overfitting. And this the concept of multicollinearity, it's like I think you have done a linear regression in some of your machine learning projects, where we do is separate the dependent and independent variables. So once we think of independent variables, we thought there is no any correlation between those features or the independent variables. But if that happens there, then the whole linear regression model is not a worth, because there is a correlation in between, then it will create the ill condition during the computation, and the interpretation of your the parameters, like the coefficient parameters, won't be easily interpretable for your machine learning design models. And after that it comes the modeling and evaluation. So what are the basic questions you have to think of while doing the modeling and evaluation are: which machine learning algorithm suitable for your problem? So these I'm giving a very small type of like ideas here based on the data size. For example, if you have a I mean less than 10,000 data set, then you can might go for linear support vector classifier. It's one example for classification. And then if it keeps on increasing your data size, then you can increase you can uplift to the ensemble classifier or stochastic gradient descent based classifier. So these are the like decision making process within the your machine learning pipeline. So you have to consider these kind of factors. I mean, for example, uh, it has been very, I mean, argument in the ML community right now about the no free lunch theorem. So that is the idea, like if you have a problem in your hand and you want to apply some machine learning algorithm, but it's like no one can say which algorithm will be best for you, which algorithm will work best for your particular problem. So you have to try and iterate with lots of other approaches and see which algorithm, I mean, give you the right performance at the end. So here is one example that I'm putting from my own research. So this is the case where you have we have to differentiate from a person is whether a male or female, and then based on the feature of height and weight. But you can see here, based on a very small changes in the weight and the bias component, the base component of the model, the different hyperplane has been drawn here. So this is the like one of the ways. I think Pankaj also mentioned about the visualization in his slide. Something like you have to think of when you do some modeling, then you have to apply some visualization to see how the model is affecting my data. Is it working well? It's able to classify the data well or not. Once that has been done, then you have to come up with some performance measure for your trained model. Like, did you get some really good validation score on your data? Then you are good to go. Then you can follow the next step. But it's not, then you have to think of some other iteration approaches, like should I include more features, should I apply the new algorithm, or should I train my model the longer time. So these are the very decisions you have to make, because I mean, some most of the time you will see that people will have some validation score and they'll just stop there, and then they want to just go for the deployment approach, or further next step. But that's not the right way. You have to just stop right here if you see there is no any good score on your validation set. Or these are the validation score means something like, for example, you are using classification problem, then it could be some confusion matrix, or recall or precision values. And if it's a regression problem, it could be some r square value, or adjacent r square value. So those are the like validation score that you have to keep in mind, and then make further decision in between. So this is one of the example that I have recently done. This is on RGB kernel SPM. So where we have the parameter sigma, and then I have to see what are the like how the parameters will affect my model accuracy, right? So in this case, I want to see after what values my model starts to underfit or overfit. So in the previous, this validation score thing is very important, because in between, what you do is you have to think of all the ways to see how the parameters, how the learning process is here. Like, is there any overfitting, underfitting, or is there how the performance on the validation set. Those are the very much the like important aspect of your evaluation process. Once you're done with your trained model, you have now in your hand, you have the trained model. Now what you do, I mean, you don't go for the deployment at, you have to think of how to tune the model parameters. So here I want to emphasize something important. So here the model parameters mean my hyper parameters, and the actual we can define other kind of parameters. Those are the model weights, like coefficients, and whatever you want to learn from your model. So during the process of tuning model parameters, people usually approach with very basic cross validation at the beginning, and then they go for a simple grid source or the random source process. So these are the like the strategy that you can follow, where you have to tune, because once you tune the hyperparameters, then you are ready to go for the deployment approach. Because the tuning hyperparameters is a very time consuming process, because it's kind of lots of computational expensive processes you have to follow. So now we go to the final step, where solving and monitoring happens. Like, once you design your model, then you have to think of uh, give some like common interface. Like, it's you have to serialize your model into a very common ways. You can think of like why JSON is very popular, because it's very common to communicate with all the web development framework or any programming languages. You can easily parse the JSON, right? This is something similar. You have to serialize your model into some serialized object, so that it can be passed to other deployment framework, where you can easily deserialize and then work upon. And once you have this process done, then you think of you will design some prediction API, or some inference API, or you have some regression output API. So I mean, those are your decision based on your problem at your hand. And once that's happened, you will simply invoke those REST APIs or any APIs you have designed from your applications. The thing is, it won't stop there, because it has mentioned in the previous presentation, it's evolving, right? Every day there is a new data. You have to monitor your user experience, or you have to see how people are behaving in your applications. And based on that, you have to retrain your model. You have to somehow collect the new data, because most of the time what happen, whatever you design, whatever you deploy, won't work very easily for the the real time scenario. And at that time, what people usually do, they usually, from the right instance, you have to collect all the data points, the new data points that has been generated from your application, and then we have to make sure we use those data frequently for the training as well. So that this concept of versioning and creating new model, or the retraining, particularly based on your application domain, because for example, we have a model which do some analysis for advertisement, AdSense, let's say, where to what kind of ad to display for the customer. For that, we need to know the customer behavior in every day. So that means we have to make sure we have to train our model, let's say, in a day, or in a span of 2 days. But there are some of the there may be some of the scene or the problem where you don't have to retrain every day. Like you can wait for, like, at the end of the month, and then see collect the whole data, and then retrain your model. So this particularly depend on most of your problem at your hand. Now, I'll try to. I think Pankaj has already mentioned so many really relevant aspect of web development, how AI will be, and most of these things will be, I think, repeated. But I'll try to emphasize more. Yes, definitely. Once you have everything at your hand, your API has been designed and deployed, and your applications is using. But you have to figure out, like, what are the major ways people are using it currently, so that you will get some ideas or the motivation. You can use your own design model to your problems as well. So one of the example, it's very prominent, is the recommendation system. It's very prominent in every aspect. Like, for example, you have designed some web application, and where you have to recommend some products to the user. Then you have to think of deploying your whole recommendation engine based on your past user data, or and then you have to deploy the APIs, and then you have to use it. So but this behavior will change every day, as I mentioned previously. So you have to come up with the idea how to monitor your model in every day's aspect, and then you use that data, monitoring data, to enhance your model for the users. The second one is very going well right now, is the enhancing the customer support through chatbot. And uh, this is working pretty well, because the natural language processing has been kind of a very important these days, to understand how customer is talking about the product, or what are the problems they are facing, and then how we can help them to overcome the problem. So during these days, people are trying to train their chatbot based on the past data of the user, how they are making conversation, or what they are tweeting outside, or how they are sharing about the product in the Facebook or whatever. So those kind of content they want to aggregate, and then try to feed into the chatbot, so that the chatbot will be more intelligent enough to respond well for your inquiries. And this is also very interesting one. I think most of you know the search engine optimization. The idea previously was on the idea of algorithm of page ranking, where the ingoing and outgoing links has the prominent effect, and the content, the different data within the website. But now, using artificial intelligence, and mainly the idea of natural language processing, when somebody search for some website, people usually do the topic modeling on top of those queries, or try to figure out what are the exact matches based on the images or the audio itself also. So these are the very general use cases that I present here, but this is the just motivation for you, how you can integrate so other components, AI as a component in your web application. I think this is my final slide. So I will stop here. Thank you.
Thank you very much, Susan Bandari. We will be starting our Q&A session. So if you have any question, please raise your hand and I will unmute you. I have one question from our YouTube chat. I would like to ask it to Mr. Susan Bandari. So Rayon Gautam has asked, uh, is there any real example about solving problems with the help of AI and ML in context of Nepal? So as you are entrepreneur yourself, so you might share your own experience on it.
Yes, definitely. So I'm not so sure you have heard about the product that we developed on meroanswer.com. It was for engineering and medical entrance preparation. The platform is still there. On that platform also, what we did is I'll give one use case from my experience so that you can relate to other problems. So we have to know that how user has been interacting, like what are the time frame people are more engaged about, and what are the flow, like it's there is a concept of funneling in the marketing. You can search about that. So we want to know which kind of people who are practicing the exam in the platform are likely to buy our subscription plan. So we want to see those kind of relation, and it was pretty much helpful because we somehow started I mean, you should not just directly jump into the problem, because you have to figure out what are the tools people are using. For example, initially we use the Google Analytics and Mix panel for gathering the ideas of how they are collecting the data, the event and everything. And based on that data, once you have the very structured data, then you can think of your own ideas, like we did for predicting what user are likely to buy the subscription plan. Those kind of things are there. And other relevant example is the e-commerce. I mean, the e-commerce, the the food channel portals. Those are like very likely to happen, because in every country there is always these kind of products going on. But these platforms also do the very basic analytics within them, how to reach the customer in the short time, finding the shortest route in the traffic, those kind of applications. But you can also think of how to use the customer data itself, how to do the some sound prediction within those customer data, or how to give more recommendation within the website, I mean, e-commerce platform in the Nepal itself. So I mean, those are the very basic ideas that I came into, but there are lots of we can discuss further also.
So I also have next question. So do you have any recommendation to some web developers or some entrepreneurs who are thinking about implementing AI in their products? So what do you think they need to start? Uh,
Yes, I think that's a really nice question. Since I worked on web development for almost 5 6 years, during that time I invest most of the time to understand the whole, like it's kind of a web application pipeline. You have to write some code, you have to understand the how testing work, how to do the testing automation, and then you need to know the how deployment work. But once you know this framework, it's pretty much very much easier for you to jump into the AI now, because you have everything, every tools very well now, how to even make the website for your final AI product or something like that. So once you have the really good idea of web application development, that's a very plus experience that you can use for your AI career. Because the domain is fairly different, because you have to know the concept of like Pankaj mentioned, statistics, probability, and the things. What I'm emphasizing these topics, because once you know those probability, statistics, and math behind it, you will be more good machine learning engineer. Because people do the machine learning engineers, do the some exercises or whatever, but those are not completely they don't give the theoretical foundation to you. You have to know how it works, because I mentioned earlier, there is a lots of decision to make inside machine learning pipeline. Even I mentioned what algorithms fits you. You never know. You have to do so many experiments. For that, you need to understand the mathematical background. So I would say there's a very high demand of both the combination of AI and web development in future, I guess.
Okay, great. Thank you for answers. So, does anyone have any other question? So I think you can have some question. Is it? So if you have any question, please raise your hand. And okay. So I will start with Sumit Yadav. Okay, Sumit, so you can ask your question.
I have learned AI and I want to join a project. Do you suggest me any?
Uh, so any of two speaker can give an answer to this. Yeah.
I think yes. My suggestion would be like I think so since you have already learned the AI and how it works, I would definitely suggest you to start with very minimal project like the very one example is could be a recommendation engine itself, like because you have really good movie data in the out in the online, you can easily collect those movie data and then see, explore your ideas how to design the recommendation engine. The thing is,
I
my
have.
advice would be don't only design the recommendation engine, but deploy it. You just some design some web interface. There will be some movies and how you can use that model to do the recommendation in the live scenario. Just designing a model and doing some validation or seeing some accuracy is not like a end of the story. Like you have to continue on the same project, because until and unless you work on connecting the dots on in between the web application or any application to AI, then it's like it's more profile for you, I would say.
Oh, sorry, I have not learned web development, but I have learned the only ML, machine learning, and the
Okay.
general about the computer vision.
In this case, like it depends on the direction you really want to go. Like suppose you really want to be a just machine learning backend engineer, then I would say, I mean, you don't have to like go further for the web application development. I would suggest to work on the like a very minimal project ideas, like I'd say recommendation engine or any natural language processing, maybe chatbot, or or any kind of vision, like you said vision, how to recognize the characters from your written text or something. So I mean, do very minimal projects which can enhance your ability to understand those problems, and then it will help you to come up with new ideas also. But you have to start with the very minimal at the beginning.
Is there any place in Kathmandu to join a project that is already running by someone?
At the moment, I am not so sure about, but I came to know that there is some machine learning companies in Kathmandu, is like Cloud Factory and I Grow by Data. Those are the companies I have heard of. Like they are working on the very different kind of projects. So maybe you can try to maybe join as an internship over there, or request them for guidelines, or I mean, I think people will be willing to help you with new ideas, or be a part of it, I guess.
Thank you, thank you,
Okay, thank you, Sumit, for your question. I hope you got your answer.
thank you.
So, is there anyone else who have a question? Please raise your hand. So I have a question for Mr. Pankaj. So Revan Gautam have asked, um, how do you train your model when working on company? Do you use Google Colab or do you use your own system? So can you please answer on this question, Mr. Pankaj?
For now, we are a small company uh, uh, co-founded by our friends. So we are building our own resources. But for now, we are using Google Colab, and in few time we'll be sooner using our own systems too. If you are sole learner, you can use Google Colab, Kaggle also. Uh, yes, that's it. You can use those platforms. They are pretty nice.
Yeah. Okay. Thank you, Pankaj, for answer. So, is there any question?
Hey, hi, Vishal. There are a few questions in the chat box. Can you please answer that?
Uh, so, Siddharth have asked, I want to make my career on AI and data science, and I have been learning continuously, but seeing several job portals and groups, one can clearly see in context of Nepal, AI and data science opportunities are extremely less, especially for a student like me who is just looking to join industry and have no prior experience, which is really demotivating. As an entrepreneur yourself, what would you suggest for a student like me? So, Mr. Susan Vandari, can you uh, answer this question? Uh,
Okay, so let me refer the question again. So AI and data science opportunities are extremely less, especially for the students like me
mm,
who is looking to join the industry and have no prior experience, which is very demotivating. Yes, truly, yes, I can feel that. Most of the time, it happens because even I mean the ideas of any career, not only the AI or web application development, anything, they really want to they really want someone has a very like high level of experience and everything. That's the like niche, you know. So the thing is, nobody born with those kind of talents to have all the the components to know, right? So the main focus would be like my advice would be decide which direction you want to go first. Once you have the decision to get, let's say you really want to be natural language processing engineer, let's say that's the domain you are very focused, then you should do you should do some projects like the minimal projects, and then you should start using those kind of products to share your code on the GitHub, or try to write some blog post based on your projects, so that people will know that you have been working on it. And then this is the right way, because most of the time even your blog or your content on the outside in the GitHub is the right way, is it gives you a route for the communication. You know, people will approach you through those kind of portals as well. So basically in AI and machine learning, it depends on how much you have put your effort to, you know, create new kind of tools around to solve the very minimal problems. I mean, don't have to think a very out of the box problem. You have to solve, maybe you can solve the very existing problem, or people have already available solutions, but just try to solve those problems and then see how your product works, and try to communicate those product to share in the Facebook group. Maybe maybe there is a really good Python group in the Facebook, or maybe you can tweet something about your product in the Twitters. I mean, those are the right ways to share your ideas to other people, and then that's the way people can approach you as well.
uh, thank you, Susan Vandari. So, I have a next question also. So, I think you can answer this one also. So, Yugand Khan has asked, uh, can you explain some correlation about AI and medicine? As you have been working into interpretable machine learning, and I think interpretability is quite important in AI and medicine. So,
Yes,
uh,
yes,
uh, can
that's true.
you uh, say something about it?
Yes, definitely. So, yes, in the field of and the medicine is a very different domain. Which I would say I haven't worked on the medicine domain, but through the knowledge of the model interpretability and the bias idea, what happened is most of the time medicine is a very critical domain. Like let's say it's like having I will give one example. Having a 97% accuracy of your model doesn't make sense in the medical domain, because you have to have the idea of how predict what is the predictive ability of your model and how precise your model is. There is these ideas which is more on the Bayesian machine learning, like how precise your model to predict the thing. And if you in the context of like how people are working right now, you can see the relevant research now in the COVID-19 also. They want to see the trend, they want to see the pattern where it's growing faster, or even people are trying to detect I mean measure the heat map of particular areas and of the human body, to see like who are the like the probable people who might have the COVID-19. So in the health and medicine, like there are so many challenges because of the it's very I mean critical, and people don't want to make AI take a decision, because I mean people usually go for the doctors first, right? I mean they this is kind of a very trust issue in the medical field, I would say. The thing is but it's helping a lot. I have seen so many papers that it's been much better to detect the cancer these days with the deep learning models rather than the doctors itself. I have seen those papers, and it's pretty fascinating, because based on the data availability, then you can train your models to make it more efficient enough to detect those kind of patterns very easily in the data. So in context of Nepal, I cannot easily give the good idea, but you can think of a very how it can help you to maybe analyzing the symptoms of the users, or using the past history of the medical diagnosis to see I mean what are the medication you have to follow, or those kind of things people are doing I think in the other countries. But in case of Nepal, I haven't seen those kind of applications. I think I will take one more question here. There is a one question about the stock market prediction. I have recently, I'll say something on this also. I have recently worked on the stock market data. You are saying what kind of data is needed for the stock market prediction? I really didn't get your question, but the data is it's called the time series data. So you can download any stock market data online. I mean it's publicly available most of the time. So for example, Facebook, Google, or maybe Amazon, you can download those stock data for these kind of companies. And what they do is they want to see the the prediction model. They want to design some prediction model, how the the historical data has the influence on the next coming days, how the prediction will be. They want to do something similar, but there are so many machine learning models relevant for the stock market. Like currently the recurrent neural network is very much popular in this area. Even people use convolutional neural network on this, and LSTM is also very pretty much popular. I have used these models to see the relevant comparison. So I have seen LSTM is doing pretty well on the stock market or time series data.
Thank you, Sujan Bandari. So I think we will end our Q&A session. So thank you all the speakers and all the participants. Before ending, I would like to ask Mr. Rasik Shrestha. He is current president of USDB to give an ending note. So Rasik Shrestha, yeah.
Namaste to all. Sorry I couldn't introduce earlier due to some technical flaws. First of all, I'd like to thank all the participants here, our speakers, Mr. Sijan Vandari and Pankaj Shah, and moderator Vishal Laka for making this event successful. Moreover, I'd like to thank Deep Learning.ai too for this event. This event by an AI is organized all over the world on the Deep Learning.ai and hosted by independent groups. So this is the first event hosted by ESCB, so please excuse us if there had been some flaws. And sorry we couldn't address all the questions due to time limitation. We'll be organizing some more events in near future, so please stay tuned from our Facebook page, You can search it by ESG BKT. So that's it. Thank you all. With that note, I'd like to end this webinar here. Thank you all of the participants for joining this event.
And at last, I also like all of the participants to fill up the survey form. And after filling up the survey form that will be sent from deeplearning.ai, you will be able to get a promo coupon, which will allow you to have a 1 month subscription with 50% off in Coursera. So grab the opportunity. So thank you all. Uh, we will be now ending this session. So.